All right, well, then we'll, thanks for your talk. Moving on to the next talk, which is Astrid from Radiobotics talking about supplier evaluation of medical annotators for AI software as a medical device. All right, Astrid, go ahead.
Yeah, thank you for the introduction. And just again, my name is Astrid and I'm a product quality manager at Radiobotics. And today I will share with you how we do supply evaluation and QC of our annotators. I'll just start by sharing my screen. Oh. I'm afraid it'll be a bit the other way around. All right, do you see it?
We see the Jitsi window right now. Or maybe it's still, if you have multiple screens, probably you have to move the presentation to the Jitsi screen, also like the other one.
Yeah, I thought I did that. Sorry. Okay, here, now I see it.
Yep, that looks good so far.
Yeah, sorry, it might be a bit slow. Perfect. All right, does it look good now?
Yep, that's perfect.
Good. All right. Yes, but I want to start off by giving a small introduction to Radiobotics. So at Radiobotics, we develop software for analysis of radiological images using machine learning. And more specifically, we focus on the musculoskeletal area within radiology. So that's joints and bones. And an example of such a software is this one called RBNE. And RBNE is intended to analyze X-rays of knee joints and provide markings in the images of findings related to osteoarthritis. And that is what you see in the image here. So to the left, you see copies of the original images with these markings that RBNE has found. And to the right, you see a text report describing these findings. And to make such a device, we need data, and we need different kinds of data. So we need the anatomy, so images of the anatomies in question, so X-rays. And we also need annotations. And annotations can be different things. So it can be markings of findings, here visualized by this red bounding box or the red arrow. But it could also be scoring of findings if the clinicians use some type of scoring method or a classification. It could also be a conclusion on an image saying in this image there is osteoarthritis or in this image there is not osteoarthritis. So we use different kinds of data. And the way that we collect annotations in particular is by using an annotation platform, which we see here, where the annotator can go in and highlight the findings in the images, and that data we can then use to develop our machine learning algorithms. And just to put it in a bit of a perspective of ISO 13485 and supplier evaluation, so data is the material of which we build our medical devices. And we purchase this data from suppliers. And since we're not the experts, how do we make sure that these annotations are of good quality? And it's also a well-known fact within machine learning that if you put garbage in, you'll also get garbage out. So we really need to make sure that what we put in is of high quality, so we can also get a high quality output to the safety and benefit of the users and patients in the end. And as mentioned before, we have two different types of data. So we have the images and we have the annotations. And the quality of the images can be a bit more tricky to control because it's a clinical reality that these will vary a lot in quality. So we have to make sure our medical device can handle that variation in quality. But the annotations, on the other hand, is a bit more easy to evaluate and control the quality of, and that I will just present in the next slide. So we use our supply evaluation and purchase control procedure, and we have developed a process with the following steps, as you see here. So when we have a new annotator, that one is, we need to do a supplier evaluation of that annotator, which is basically based on the qualification and the experience of that supplier. And it's typically a radiologist or radiographer that we need to do the work. And after the evaluation and approval of that supplier, we can start the annotation tasks, and this is where the incoming inspection of data comes in, or a QC. And this has two branches, so we have an onboarding QC and we have a continuous QC. And the onboarding QC is in the beginning of an annotation task to ensure we have a good performance initially. And the continuous QC is then done for each batch of data that an annotator annotates. And this is the purpose of this is to monitor any drift in performance over time. So we also can evaluate that. And if we just look at the onboarding QC, then the methodology is that the annotator is trained in a specific annotation task using an atlas, which is basically a how-to guide on how to annotate this particular anatomy and findings. And then they are given a batch of images that are already validated, so we have ground truth data on this batch of images. And because we have ground truth, we can calculate some performance metrics. So, for example, false negatives and false positives and agreement with the ground truth. And after the annotation of this batch, we get a report out with these different metrics. And that is what is shown to the right, basically. So every row is an annotator. And here are some performance metrics for different features B and C. And then there's also a decision based on these performance metrics if this batch is passed or failed according to a predefined acceptance criteria. So if that batch fails, then we have an opportunity to use this performance report as feedback to the annotators with the exact examples of the images that were false positive or false negative. So this is a great way to continuously train the annotator. And then they give another batch, and then the process is repeated. So after this, we can then decide to proceed with the annotator or stop. So this is the onboarding QC. And the continuous QC is then, when the onboarding is done to satisfaction, then they can, then we set them up with a bunch of data they need to annotate that comes in batches. And to evaluate that performance as well, we use this method where which you see to the right, where we have 3 annotators annotating each 120 images, where the 100 of the images are different for each annotator, while 20 of them are in common. That means that we have an overlap. And this overlap we can use to see if they, to compare against each other and to see if they agree on the annotations. We can also do some individual performance metrics for the annotator. And of course, this overlap can then be adjusted to the annotation task at hand. So it could also be that all images were overlapped, so you had basically 3 annotations on the same images. It depends on the annotation task and the risk of those. Yes, but this is then repeated for each batch they get, and then it's shuffled around. So one annotator is always compared to some new ones. So in that way, we have a chance to see if there is anything that we need to do actions on. Maybe the annotator is not performing so well, or there's something with the images. We have at least some kind of evaluation and control of the annotations also continuously. But this was basically what I wanted to tell you, and I hope you found it interesting. And if there's anything, you're welcome to reach out if you have questions or comments.
Cool, thanks a lot for your presentation, Astrid. Maybe one question which came up in the YouTube chat was whether a supplier is actually a person or a company in your documentation.
Yeah, so that's a good question. So it can be a bit of both, but right now we mainly use one-person companies, so to speak. So it could be a radiographer or a radiologist, so that is on a person level. But there is also companies where it's the company you would look at, and then they can employ different annotators. And it would still be the same thing we would do, but maybe we would just have one supply evaluation for the company and not for the individual person. But the QC would still be on the annotator level.
Cool. All right. Great. Thanks a lot. Thanks for your presentation again, Astrid. And yeah, have a nice day, and maybe see you at 2:30 at the Ask Questions About the Talk thing if you have time.
Yeah, thanks.